Lesson 5.2. We're going to learn how to verify trigonometric identities. That means we're going to prove that they're true. And so this is building off lesson from 5.1. And so 5.1, we talked about different identities, which things were that we found that were true. Now, the first thing we started off with were reciprocal identities. There were 6 of them. And so here I have reciprocal. I have the 6 here. We found that sine theta is the same thing as 1 over cosecant theta. And cosecant theta, for that matter, would be 1 over sine theta. They were reciprocals of one another. And this would be true. There's 6 of them. These were the sine and cosecants. There were also secant and cosine, and as well as tangent and cotangent. These are found in the formula chart under reciprocal identities. When you go there, these are the 6 right there. We had those. And I'm going to just give you the overview of the other ones real quick. The next thing that happened was we looked at quotient identities. The quotient identities is that tangent is sine over cosine, and this came from the song psi y cos x, tangent is y over x. Tangent is y over x, and sine is y, and cosine is x, and tangent is sine over cosine. Well, its reciprocal is cotangent, and so cotangent would be x over y, also known as cosine over sine. Then we moved on. We said there's 3 Pythagorean identities. Starts off with sine squared plus cosine squared equals 1, and then we have tangent. These were also on the formula chart under Pythagorean identities. There's those 3. Now, as we move on, these were not on the formula chart. There's cofunction. There were 6, and that's you could change from a sine to a cosine by starting the cosine at pi over 2 and taking the negative of the angle. So moving to the right as the unit circle goes. So what I'm saying is this. Instead of, normally theta moves from the x-axis going upward. And so if you had the sine going this way, you could say it's equal to the same thing as, whoops, I'm sorry about that, cosine going, if I can ever get it back. It's the same thing as cosine going this direction, starting from pi over 2. That's pi over 2 there, and working this direction. All right, and this would be true from sine to cosine, cosine to sine, tangent to cotangent, cotangent, back and forth, those 6. Finally, we had even and odd. We found that cosine is even, which means if you look at an angle, let me take this away here, for even and odd, for the even functions, that means that no matter what, if the angle's going upward or downward, you get the same answer. Notice that the x value here, if you had a point, if I had this point with a positive theta, or this point with a negative theta, you see how the x value is the same? So if it involves x, it's even. Cos is x. So cos is even, as well as secant, because that's the reciprocal. Secant is also even. So it just means that no matter what, if you have a positive angle or a negative angle, you're going to end up with the same x value. Odd means it won't be. It'll actually be flipped across the origin. So for example here, if you took a negative angle, and so a negative angle would go this way, and you have a point, well, the y, notice, is down here. It's negative. It's a negative y value. Okay, now that's the same thing as sine with the positive. So here's the positive going this way, and whatever y value you get here, whatever this y value is, you then make it a negative, and so it would give you the same answer. So that's why it is odd. So a negative angle for anything that's odd is like moving the negative to the front and having the positive angle. So that's what that meant from last class. So there's 6 of those as well. Cosine and secant were the only 2 that were even. The other 4 functions, sines, cosecants, tangents, and cotangents, were all odd. I should make a note here. These were the even. These were the odd. But this was all last class. Okay, building off that. Longest introduction ever. Well, and saying that, there were 4 strategies from lesson 5.1. The first was this. If we're trying to simplify, we can change all trig functions to sine, cosine. Second, use Pythagorean identities. Third, we could factor. Fourth, apply conjugates. And technically speaking, we could also, I'm missing a parenthesis here. I need to add it. Let me pause this video. Just like that. We now have the parentheses. Okay, we can apply conjugates, which just means that a squared minus p squared, the perfect square, comes from these 2 values. Now, truthfully, there is the 5th term, is that's applied to any of those other identities we had. But these are the typical 4 strategies that we use. Now, I'm just going to stop it here just because this has been such a long introduction, and we'll start on example 1 in the next video.